The first question I got wrong asked which of the following times is the force exerted by the elevator floor on a passenger the least. So before we answer the question, we'll draw a free body diagram. And what we see is that there are two forces acting on the passenger. The weight and the elevator floor, which we can label as force normal. So for the elevator's floor's normal force to be the least, the acceleration must be the most downward possible, which means that weight must be much more than the normal force. So we're given a graph of velocity versus time, and it looks something like this. So from the following situation, as what I just described, this means that we need to pick the time where the acceleration is the most downward. And so if we look at the velocity versus time graph, the option that gives us the most downward slope is the correct answer, and that would have to be at 6 seconds, because the slope is going to be like this. So from the following equation, frequency is doubled, and so will angular velocity. So from the following equation, we have for the force, then by doubling this, we're actually quadrupling the force, since angular velocity is squared. Since the center of mass does not move, the upward force tension must equal the downward force weight, but the tension force does apply torque to the cylinder, causing the cylinder to accelerate angularly. So we have a torque.
Because it has to deal with
And you can rewrite this as RT equals our rotational inertia.
No, it doesn't. The recording already stopped anyway, so you good, bro?
Times our angular acceleration.
Nah.
We can then rewrite this as
Yeah, I just drew it out real quick, just in case you
tension equals
-7.
1/2 MA. And then keep in mind that tension equals mg. So we can do
I got it wrong. It asks the net force from the cylinder.
1/2 MA.
But T minus mgr is because.
And then from here we can see that acceleration equals 2g. So our correct answer is 2g. If the person moves to the other side of the raft, the center of mass of the system will be a distance d on the other side of the center of the raft. The center of mass will have traveled a distance 2d across the raft, but the center of mass doesn't move. The raft is what moves, and the center of mass remains in place. Therefore, the raft is what moves 2d to the right, so that the raft center is a distance d on the other side of the center of mass. So our answer is 2d. If the speed of the car increases about 3 meters per second every second, it takes 20 over 3 seconds for the car to reach 20 meters per second of velocity. Power equals work over time, and the work done to accelerate the car is equal to the car's kinetic energy. So here we have the equation for power. If we substitute work for kinetic energy, we get 1/2 mv squared over time. Then we plug in our givens and we get the following.
I did not help that.
Which is, so yeah, because only internal forces act on the system, the center of mass is not going to change its location. So
Is it going to change, John?
no, it's not going to change.
Okay.
So now
Then this equals
is going to be that's what there's going to be across
60,000.
the
So our answer is 6 to the power of 10 to the 4.